Hello everyone, my name's Pablo with the Cal Poly Pomona Solarboat team. And today I'll be showing you how to import JavaProp geometry into Solidworks. And if you don't know how to download JavaProp, there should be another video on this channel on how to do so. And a few things you want to consider first is making sure if you're designing a boat propeller to go to the options tab of JavaProp and click water to change the density to water because it's very different, and as well as the viscosity. Um, so yeah. And then from here, once you put in your data you want or your measurements you want your propeller to be, you can go to the geometry tab and click save. And then you can see, type in the name of your file. As you see, I'm on file 5 because I've had to re-record this video a few times. And then because JavaProp's a little older, you have to type down your file type. So in this case, I'm putting .igs after the name of my file, so it saves as an IGS file. You hit save, and then you can go to, sorry, this was the old one I was trying to work on. You can go to SolidWorks. I'll just click new part, and then you can go to open, and then usually, sometimes it won't pop up if it's only opening as a SolidWorks file. So you can go to here, and then you can go down to your tabs to IGS, and then that's usually how you find it. So you open it up, and once you click no and running diagnostics, the first thing you want to do is break the link. And now you see how it imports is as a surface and not as a solid body. So first you want to fix that. So you go to your surfaces tab, and if you can't find it, you can type in surfaces here, or you can right click here on your little tabs, and then you can check surface over here. That's somewhere here. Yeah. So from there, you click fill surface, and you want to click the edges of it. So this is the first one, and then on the other side, there's another little surface that you have to click. We weren't able to figure out how to do it in the same surface, I guess, step, but this should work the exact same. Next, you want to make sure the surface is knitted, so you click knit surface, and you click all the faces, so the main one, that tiny one, and then this one. And you want to create it as a solid and merge entities. And sometimes it won't work, and that's if you have gap control on, so just make sure to keep that off. So from there, now you have a solid blade, but you want to make sure that it's correct, and you can add the other 3 blades as well as the hub. So you want to go to whatever plane this is lying flat on, and create a sketch on it. And then from there, you want to go from the center, and you want to make sure that it's the right like length or radius or diameter in this case. So from here, you can see the radius is 125. Let me just make sure I can find the closest one. Usually the like tip of it will be perpendicular, like about here. And then just so you can be sure, you can check that, and then you can smart dimension this, and you see, let me just make sure this is in the right one. There we go. You can check, it's 0.25. And then once again, it has some that's over, but usually it doesn't matter if you check. It's very, very minimal. That probably won't even be picked up on however you're creating it. But if you do want to fix that, you can always make another outer circle and then extrude it, or cut extrude like this, but at the center of the circle. So from there, what you can do is, I'll just cut extrude it as well. It's a little easier. Extrude a cut. We can just make sure it's cut the right way. We'll just do mid plane. Yep, and then boom. You go, and then now you have to make a sketch on the top plane. Yeah. And this sketch will be for your mirror tool. So you can make a line and then do construction. Let me just make sure I put that right. A line, construction, and then midpoint line. Just get a little closer. Midpoint line, construction. Boom. There you go. You can create that as a sketch. And then you go to your linear circular pattern. And make sure to click bodies. And then click your blade. And then from there you put your direction. Which in this case it's that center point line. And you'll put the amount of propellers you have. And from JavaProp, you'll list down the amount of propellers you want. And it will change like your efficiency and the other things you put down. In this case we have 3. So from there that looks good. So now you want to make your hub. So to do that, once again you need to make another sketch here, and you put a circle, and then usually you want to go to this edge right here. So you make that. And then you see the other ones are the exact same. And just because we want our hub to have an open center, you can just put that there. And then let's make sure this is fine. Do 0.024. That's good for now. So you would now extrude it. And then typically for a rule of thumb, you want your hub, I guess your hub length to be 1.5 times the diameter of the full, the full 1.5 times the diameter. So in this case it's 37.5. Usually you have to add a little bit more, because if not, you won't be able to, you'll just have to be right at the edge, and it'll be a potential fracture point. So in this case we just round up to 0.04 meters. You can make that, and you see now it looks good. And from here we're gonna do a fillet. This should be around 0.3. We can try that, and then just these edges. It may have been easier to do the mirror after, but this is fine. Maybe it's a little too big. Let me check. Okay, once I figure this out, I'll show you. Okay, I found the problem. All you do is just decrease your fillet value, the radius of your fillet by a good amount. Okay, from there you want to chamfer one side so you know which one's your leading side. So you go to chamfer, and then this one should be fine like this, and then this one's the leading side. There you go. And I'm still trying to figure out the best way to know which one's the leading side, so you gotta bear with me as well. Let me see. Make sure I have it right. Let's see. Maybe too big. 1 millimeter. There you go. Now from there, your propeller is fully done. If you want to add a keyhole or something, that's up to your own discretion. For now, I won't add one. so we can start the simulation. So now you go to Solidworks Flow Simulation. And if you don't have this here, what you need to do is you might need to download it through your settings, which you can add. And yeah, that one should be easy to find online. So you go to add-ins, flow simulation. So it's going to open up eventually. Let me just make sure. Oh, actually, there's one thing I'm forgetting. So here, what you want to make sure you have is first you want to have another circle a little bit bigger than the diameter. And then make sure that it's covering the whole prop. Usually I like to do blind since doing midplane right now is kind of tricky. Then yeah, so you can do like 0.05. That's good on this side. Yep. And then this could be like 0.02. Yeah. Make sure that merge result is off because you want to have that off. So you can click yes and then change the transparency so you can see your prop. Okay. Now you can do the flow simulation. So once that's checked, you go to this tab and then you go to wizard. Oh, don't forget to save. Let's keep that the same. Go to wizard. You can name it. I'll just do prop test 6 since that's the one we're on. There's a few features you want to have. So in this case, you want to make sure that rotation's on. And then fluid flow as well. And for your liquids, you want to put water. Usually, unless you're putting this under another liquid. Turn off cavitation. You can just click next on this one. And turn off pressure potential. Okay, you can click finish. And now there's a few more things. So you want to edit the domain just so it's not a huge box. You can just shrink it a little bit. There you go. There you go. There you go. And then let me just increase this as well. Let me see. Maybe this could be a little longer. There we go. That looks good. Click that. Rotating regions. So now you want to click the circle that you made. And you have to put in your angular velocity. So this is just, if I remember right, to angular velocity. You just do this with your RPM. You can convert it. And then RPM to rads per second. That conversion is 2 pi over 60. So if you multiply 1,200 by 2 pi over 60, it's about 125. And then depending on what you have, it may differ. And then that should be everything. So from there, you can run it. And depending on if you made like a model similar, it might take a bit. So in this case, it probably will take a bit. So I'll come back when it's done. Okay. Now that the solver is finished, you can go out of that. And you can go to results. You just click this little drop down. And you want to do flow trajectories. You insert. And you want to insert from this edge 1, your leading edge. And you'll type in however many arrows you want. I usually like to go with 40. And then I like to have lines with arrows. It just makes it easier to visualize. And here, change it to velocity. And then once you do that, it'll run it. And you can see that you have now a simulation on this. And if you want to play it, you can play it as well. So you can see all the little arrows go in. And then they go out. And yeah, so that's pretty much it. Thank you for watching this video. If you have any questions, you can feel free to leave it down in the comments. Hopefully I'll be able to figure out how to help you. But yeah, thank you.